Hey, this is Jim from DTRSec. This is the 5th video in the Reversing in REnigma series. We will continue diving into the nasty executable malware sample we recorded in the 3rd video. In this video, I'm going to give an in-depth overview of the network analysis section on the recording details page. Let's do a quick overview of the network analysis process in REnigma. During recording, REnigma automatically generates a packet capture, or PCAP file, to save all of the network traffic. We can then use any tool that understands the PCAP format to analyze that data. The REnigma web interface processes the PCAP data and shows a summary of all network flows in a table on the recording details page. The columns in this table include the remote IP address, the domain name, and the port number. If a domain name is not used in that flow, then unknown host will be shown as the domain. Additionally, we include the first packet number, the bytes sent, and the bytes received. The first packet number allows you to correlate that flow in the PCAP file. We also allow you to download the full PCAP file and TLS session keys. This enables you to analyze your recording's PCAP data in tools like Wireshark, T-Shark, Snort, and Suricata. The TLS session keys also allow you to decrypt certain TLS network flows to see through the ciphertext and get the original plaintext. Last, we will discuss this particular malware sample's network behavior. When we look into it, we see lots of repetitive network flows to unknown hosts. We also see some connections to .ru domains, which is totally not sketchy at all. Now, let's take a look at this in the REnigma web interface. First, start on the REnigma homepage. Then we click on the Recordings tab. Then we click on the Expand button for the recording we want to examine. And then we click on the Details button. And now we scroll down to the Network Analysis section. Now we see the table of network flows. You can see the remote IP address, domain name, and port number for each flow. And you can get the first packet number in the PCAP, as well as the number of bytes sent and received in that flow. Now, let's scroll down to the bottom of the table. At the very bottom, there are links to download the full PCAP data and the TLS session keys. We will make follow-up videos describing how to import this data into Wireshark and T-Shark. This allows you to use REnigma as a data source for your own custom PCAP workflows using any tool you like. Additionally, we are happy to announce that we are currently building automation to analyze the PCAP data with Suricata. This data will be used to populate the alerts section in the recording details page. We will also expose that data in the REnigma API and in command line tools in the REnigma console. With this capability, you can also use REnigma to validate your Suricata rules using a corpus of REnigma malware recordings. We will make follow-up videos demonstrating these capabilities as they come online in 2025. Now that we've talked about the network analysis features of REnigma, let's take a look at this specific malware sample. As you can see, the unknown host flows are all very similar. Each appears to send about 1907 bytes and receive about 4516 bytes back. We also notice the first few flows do not receive any bytes indicating that those IP addresses were no longer online at the time of the recording. We also see some connection attempts on port 80, even though most are on port 443. And we see a couple of connections to a .ru domain on port 80 as well, sending and receiving a few kilobytes. This network data is your starting point for analyzing any malware sample and can be used as an initial anchor point for later REnigma analysis. And that's all for now. If you want to learn more about REnigma or are interested in evaluating REnigma, please visit dtrsec.com. Thank you for watching, and I hope you enjoyed the video.